Please turn on your cameras a bit for a minute or two. Okay. Not having a. Sometimes when a person try to enter the meeting without our dominio, I don't know how to say dominio in English. They have to ask. So I'm going to enter what? I don't get any message like that. But well, I'm going to share my. Okay, yeah. There's a message. Allow Paloma de Jesús. Okay. Good morning, Paloma.
Hello, good morning. Thank you for accepting me.
No problem. You can see my students.
Yeah, good morning, guys.
Good morning.
Okay, we are going to begin our class. I'm going to present I'm going to share my screen. Okay, there is. Okay, today we're going to have our last activity. It's we're going to summarize all the topics we saw last week. And you're going to make a presentation of your simple design activity that you did last week. You need to include all the steps to simulate the operation, also to generate the G codes. And we are going to have 3 stages or steps in this presentation. First, you're going to explain the steps needed to manufacture your simple design. Then I'm going to simulate the machining process to verify that there is no collisions. And finally, there's going to be a question and answer section. Your classmates or myself can ask you something. And then we're going to change to another student. Today's roster is like that. First, Janet, then Jose, Daniel, Luis Campos, Miriam, and if we have time, Sofia. And next class, next Friday, the rest of the students, okay? So I already have your PowerPoint presentation in my computer. So I'm going to start sharing the Janet PowerPoint. Let me change for that. Are you ready, Janet?
Yes, teacher.
Okay, let me share my screen.
Well, I'm gonna present my tutorial design time. It is made in a simple form because it was made for showing you the CAM tools of the Fusion program.
Next.
Yes, teacher, please. Well, the first thing that I had to do was creating the sketch. It is according to our design. You can do whatever you want. So I wanted to do this simple design with the letter J because it's the first letter of my name. So it is simple, and I only give the measures of each each part of my piece in this step. Next, teacher, please. And in the second step, you need to extrude the circle and give a desired measure. I defined this measure to 20 millimeters. And then I extrude the letter J to, I guess it was 50 millimeters. And I create another sketch to only put 2 points for doing the holes. And in this section I only define the depth of the hole and on the diameter of each hole. And in this step you can select the material of your piece, and you can select any material that you want to use. In this case I select aluminum 6061. And in the next step I change to the manufacture mode in the program, so I could begin with the operations to manufacture this piece. The first step, I define the stock diameter. I left 1 millimeter material because in the next step I needed to have extra material to remove it. So in this step I put 21 millimeter. In this step that was facing, in this step this operation removes all material from the top of the stock to the top of the model. That's why I left 1 millimeter from the stock. And in the image you can see the simulation that the tool is removing the material from the top of the stock. And I selected a tool with 50 millimeter of diameter, and I selected this tool because you can avoid wasting time. In this operation I selected the contour of my letter J because in this operation that is a pocket. This creates a rubbing operation that uses toolpaths parallel to selected geometry. That's why I select this operation. And I only change the section that says that you can select start to leave, and I didn't select it because I don't want to I didn't want to do a finish passes. That's why I didn't select stuck to leave. And in the second operation, that is drill operation, I selected a tool according to the diameter of my hole that was 10 millimeters. And in this operation, obviously the drill operation make the holes, and I only select the geometry of each circle of the hole, and that's all for this operation. And in the second operation of drill, I selected the, area of the hole, and I selected the geometry of each circle of the hole, and that's all for this operation. And in the second operation of drill, I selected the area of the hole, that was 10 millimeters. And that was that I use a tool of 10 millimeters too, so I could select that part of the hole. And in the last operation, I selected pocket. I use a 10 millimeter tool for doing the last operation. I selected the geometry of this operation, and I didn't leave stuck because I didn't want to make another operation for finishing. And in the image that the piece is like in green, you can see how the tool makes the operation. And this is the final simulation of my on my piece, and you can see how you how it was made by selecting directions and of the tool. You can see the the finishing because I didn't leave stuck, so it is completed. And that's all. No, I forgot to say about this. I generate the G code, only selected an option that is called post process. You only select the type of machine that you are going to use in your manufacture piece. So the program gives us the G code automatically, and you only have to save in your computer. And that's all, teacher.
Okay, pretty good. I'm going to present the simulation. Let me change. And share again. Okay, can you see that?
Yes.
Well, this is the piece that Janet designed. I'm going to simulate the tool paths, the trajectories of the tools. Okay, we have a preview of the first operation. Okay, okay. The stop and collision option is selected. Okay, but as you may remember, here we have a green area. If the area here is green and without any red point, it is okay. The operation is okay. Okay, but let's start to see it. Okay, this is the facing, and as Janet told us, we can see the removal of the material. Now we have the 2D pocket. Also without any collision. Okay, I'm going to take a deeper look here. Okay, as you can see, we don't have any material to be removed by a finishing operation, like Janet told us. Now we have the first rail. Oh, that was quick. And now the final pocket. Okay, here we go. There is not any material to remove there. Okay, like in the second hole. Okay, guys, any question to Janet? Any comments? Speak freely, guys. At least say no.
No, teacher.
No, teacher, we're good.
Okay, next one. I'm going to stop sharing my screen. And who's next? Sierra, are you ready, Sierra? Lupin, are you ready?
Not, but I have to do it.
That's the attitude. Okay, I'm going to start projecting your PowerPoint. Okay, let me share the screen. There it is.
Good morning. My name is Jose Guadalupe Sierra Esquivel, and I'm going to present you my design project. In this slide, we can see the model that I made. There are only 4 main operations that will be made to the stock piece, and I'll show you in the following slides. Please, next. The first, before, I have to mention that I left 1 millimeter on the top of the stock that will be helpful to do the next operation. That is this. The first step is a face operation. It is used to remove the exceeding material from the top of the stock that I left. Here we can see the toolpath. It only passes once over the stock because it only has to remove 1 millimeter that I left. The next operation is a pocket, 2D pocket. This is used to remove material from the area that I selected, that is colored in red. Because of the last operation, there were some material that were left. I had to add an additional operation to remove the material left. So I added to the adaptive clearing. This is used to remove the material left by the last operation. For these 2 operations, I used a preset tool which diameter was 3 millimeters. The last step is a drilling operation that I used to make the 4 holes that are seen in the model. this one that are in blue. I used a personalized tool because the holes were 5 millimeters diameter, and I had to create the tool. So I did, and I use it to do that 4 holes. Thanks for your attention.
Okay, let's see your file. Let me stop sharing this screen. I'm going to return to the Fusion software and select your design. Okay, let me open it because I don't have it open. Wait for me a second. I'm going to open the file. Open from my computer. Your single design. Your not married design. Okay, here you have your design. Let's make the generate the simulation. Okay, let's play it. Okay, here is the removing of the stock 1 millimeter. Okay, pretty good.
Yes. As you can see, it only passes once. That's the
Now,
next operation.
you told us that this operation is going to leave some material.
Yes.
Okay. Okay, you also set the parameter to left no material to avoid finishing passes.
Yes.
Yeah, we can see it there. This is the adaptive, the 2D adaptive, the operation that is removing all the material according to your design. So you left the colorization to the operation, okay, to the stack operation. That's the way that we can see the difference between each of the steps that you took.
Yes.
I'm going to speed up a little the simulation. Okay, that's the last one.
Yes, the drill operation.
So you have to create a new tool in order to do it.
Yes.
Okay. Yes?
And that's all.
Okay, any question, guys? Any comments?
Not sure. I don't have doubts.
Okay, it was an easy design, but well done, okay?
What is it though? Like, what is it for?
Lupin, what is that, Lupin? In other words.
I don't know. I made it because I had to, but I don't know what it is.
Okay, you just did it in order to satisfy to make the assignment.
Yes.
Okay, I'm going to stop sharing my screen. And next one. Campus. You did it, Campus. You are next one. You make it just in time.
Right there. Good morning.
Good morning, good afternoon.
And good morning as well to the lady that is here in the call.
Good morning.
Good morning, Lupin. So I
Campus,
presented by myself or to teacher.
as you like, Campus, I already download your PowerPoint and your design. You choose.
I guess it's better because I put some hyperlinks, so
Okay,
the hyperlinks move to another files on this computer.
okay, you may proceed then.
All right, thank you. Oh yeah, also please forgive me for being late. It wasn't my fault. It was internet connection stuff.
Oh, okay.
Can you see my screen now?
Yes, we can.
All right. All right. So welcome everybody to my presentation. First of all, I introduce myself to the people I don't know and she don't know me, right? And well, my name is Luis Campos. I'm a student from UTLD. I'm currently coursing the ninth quarter of Industrial Process Career. All right. Yes.
Yes, all right.
Right now, I'm here presenting to you my final activity of the subject Advanced Designing and Manufacturing. I guess, right? Yeah. Well, so I hope you enjoyed your time here and like this work I did. So let's get started. The name is Simple Design Camp, and this is a word which I put into practice some of the learnings I got in class using Fusion 360, both designing and manufacturing by milling. So the first slide, we have the designing process. As you can see, it's a simple design, and this is about choosing and designing a model in which I include models operations seen in class. What do I mean by this? As you may be able to see, there are some cavities on the final result that is here below on the bottom, and there are some holes also. All right, where's next? And the next slide, now we move to manufacturing, to the manufacturing workspace. And here we need to prepare a setup on Fusion. Right, there's an operation sheet where we can see the option to create a new setup, and we get into this by clicking the right click and choose create a new setup, and these two tabs showed up, and here we can select the machine, the axis, the stock to remove. Well, we can add some offsets, and we only need to select the machine and the size and the shape of the model to manufacture. The machine selected is a generic 3-axis. This means the tool can move through all the spaces allowed to in the axis X, Y, and Z. And I mean by this, up and down, right and left, front and back. And also I selected a different mode from the given by Fusion, and I did a relative size box. So it allows me to add some offsets, and it gives a tolerance, a big tolerance, so we can't damage the model. And white box because it's closer to the shape of the model. All right, now we move to the second operation. It's a 2D pocket. The tool selected for this operation is a flat one due to the face to machine is a like full horizontal face. I mean, there's not a vertical face to machine, so I choose the flat one. In the geometry trap that showed up, I don't need to select anything on that because Fusion by itself recognize the top of the figure. And oh my god, I got lost.
Yes, you have to explain to us first the facing operation. We are seeing that already in your screen, the facing operation, or the to the pocket.
Oh yeah, you're right. Oh yeah. The first machine is the facing.
Yeah.
Yeah, you're right. Here in Fusion 360 recognized by itself the top of the figure. So the only things to change are the tool that is going to be the only one that Fusion gives. And I select multiple depths, as you can see on the right tab, because of the offset I added on the setup configuration. The feed and speed, it's all set by default by Fusion, because I guess it's because it's the best option for the material and stock relation. Now, if you may, I can move to the next one. The next one, and this is the 2D pocket. The 2D pocket, the tool is a flat one, and we need to select in geometry we need to select the chains that is going to be like the boundary for the space to work for the tool. And as you can see in the figure, the boundary of the faces highlighted on blue. And what else? The tolerance is 0.1 millimeters, so it's going to be very, very close to the original model. And I added a finishing passes, so it can be closer. It can be closer even to the original one. And stock lip, I set it to a very, very small quantity because I wanted to be like more real and to look like the original model. And I guess there's not other thing to change in this one. And in these ones. All right, in this operation, it's a center drilling. Why this one? Because it will help the tool for the next operations, because as you can see, there are some holes behind this. And the tool for this, I was created because the ones that Fusion gives doesn't require the things I wanted to. And so the ones that Fusion gives damage my piece, so I need to create a new one that is a higher length, a higher overall length. So Fusion, all right. The type is a center drill because it gives like a wide to the next operation for the hold, and the length is 15 because of the first hole is also 15 the depth, so it can barely touch the second hole, and so it will help for both holes. The center drill 2 is a 8mm because of the second hole is also it's a diameter of 8mm, so it's just exact as the second hole, and it won't remove more or less than I needed. And in geometry, I selected the faces of the 3 holes, so the Fusion localizates the center of these ones. All right. Next one is again a 2D pocket, and the tool is the same that was used in the previous 2D pocket operation. Well, this operation, how do I say? There's nothing much to see because it's only selected to the faces, and it do the same as the previous 2D pocket. So I guess the only thing to do is to select the faces, as you can see on the right, and that's it. All right, next operation is the drilling operation. This drilling operation goes through all the model, so it can be more real to the original one. And it went through all the model, so the tool is 5/16 of an inch, and that's a diameter because it's the closest measure to 8mm that I mentioned before, is the measure of the diameter of the hole at the bottom. Right here, in geometry, the whole faces were the same, just like the previous operation for center drilling. And what else? Well, it traced the toolpath, and that's it, no? And that's it, isn't it? Selecting the faces hole, it localizes the center and trace the direction the tool will follow. And in this one, I need to make a modifier on the bottom height, so the tool can go through all the model. As you can see on the right tab, there are some like peaks on blue, and it shows that it goes through all the model. And the offset, I modified it to -3mm. And now the final step is on the setup stock, a box was selected. So there's still material needed to remove. And since it's around the stock, the operation needed is a contour operation. And here the tool selected was the biggest one, Fusion first, so it can remove more material. And to mention, the tool is a flat one also. And geometry, it must be selected the contour of the model did on designing. And I add some step overs so the tool can remove all the material around the figure. And as you can see, I saw the boundary is highlighted on blue, as well as some boundaries on the previous ones. Feet and speed is also set by default, and the diameter is 16 because it was the biggest one. Fusion first. And now all the steps are done. And to see the final result is just to click on setup and then on simulate. And so here's my work simulated by Fusion. And so let's have a look on it. So there is my figure, and as you can see at the final of the video, I unchecked the model option, and you may saw that the 1.1 machine was very similar to the original one. And as the final step, well, as an extra step, it was required to create the G code, and the G code gives all the steps that Fusion made to create all the toolpaths, all change of tool, or well, it describes all the steps to create all of this. And now, could you tell me what you see, please?
Okay, we are seeing your last slide about the G code. I think you're trying to present us your G code.
Oh yeah. Let me do something. I need to stop presenting to present all the screen. So now here's the G code that was generated by Fusion. As you can see, there are too much steps. On this side, you can see all the steps that took Fusion to create all this simulation. And there were more than 780. So that's much. And that's it, I guess.
Okay, thank you. Thank you, Campos. You already did one of the steps that I want to do. That was the simulation, but it's okay. I don't know if some of your classmates have any doubt, any comment. I would like to say that it was a very detailed explanation that you did, and also the piece have some interesting characteristic, interesting geometry. So you have to be very careful selecting the parameters of your machining operations. It was very good. Esaú, something to say? Victor, Miriam, don't be shy. Okay, looks like there is no questions or comments. Too bad, guys. I'm going to give you 2 or more points if you ask something. But well, I think you don't like that extra points. You're happy with an 80, right? Okay. Next one, Daniel, do you want to share your screen or I have to do it? I have to do it.
Could you share it, please?
Okay. Your design is called flange, right? Okay.
Yes, sir.
Let me look for your PowerPoint. Okay. Okay, I'm going to share my screen.
Okay, good morning, everyone. As you may know, my name is Daniel Guerrero, and I'll be presenting my last activity of this subject. It is called flange. Can you go to the next slide, please? Okay, my design. Well, I started with creating a simple design as shown in this picture. Well, in this picture you can see my dimensions, which were pretty basic, like simple. I did not want to complicate myself, so it was like a simple sketch. The physical material I added was stainless steel 316 L. Well, I added this because I already know that this material is better than the 304. Well, the main difference is that this stainless steel 316 has molybdenum on it, so it helps to stop corruption. How can I say corrosion?
Yeah.
Yeah, you get me? Okay. So yeah, that was it's like a better type of stainless steel, basically. Can you go to the next one, please? Okay. Once the design was done, I went to the manufacturer tab on Fusion 360, and I created a setup. Okay, and once the setup tab popped out, I selected the generic 3-axis for the machine and milling for the operation type. For the operation type, yes. And for the stock tab, I changed where it says mold to fixed size cylinder. And finally, I changed the length to 8 millimeters, which is the length of my piece. So basically, I left no material to remove. Like it was the next feature was the face feature. This was a simple feature, just use it in order to remove the dirt material from the stock. As I told you before, I did not leave material to remove. Well, I selected the only tool that appears in Fusion. It has a diameter of 50 millimeters. And I selected the geometry, the one that appears in this picture, which basically was a contour of my piece. Can you go to the next one, please? Then was the next step was a 2D pocket feature. Okay, basically for this feature, I selected the geometry that appears in the presentation, and I selected a tool which has a diameter of 3 millimeters and a length of 12 millimeters. And this type of tool is a flat end mill. Can you go to the next one, please? Okay, on the passes tab, I unchecked the box that says stock to lip in order to get rid of the material that we don't need. Okay, so I did this like to get a smoother piece. And then I also unchecked the box that says finish and passes. Okay, but I did not change the parameter though. Like I left them as it appears in this image, in this picture. Can you go to the next one, please? Okay, then I did one of the drill features. For this feature, I had to select a different tool. And as you may notice, these holes have a diameter of 5 millimeters. So that's the type of tool that I selected, 5 millimeters. And finally, on the height tab, I had to check the box that says drill tip to bottom in order to drill the whole piece. Because if I didn't select that, if I didn't check that box, like the holes were just going into the middle. It didn't drill the whole piece. Can you go to the next one, please? Okay, so basically I did the same thing that the last step, but I selected a tool of 20 millimeters of diameter to drill the bigger circle of the flange. And then for this feature, I chose the same tool that created the 2D pocket feature. For the geometry, I selected the ones that is shown in this picture, which are the inner and external circles of my piece. And finally, on the passes tab, I check the boxes that says multiple passes and repeat passes, leaving the following parameters, like for example, number of step overs 2, a step over 1.5 millimeters, and I just check the repeat passes box. I did this just as I have, just in order to have like a smoother piece, like a better piece, a better manufactured piece. Okay. And the last step that I did was I did the same for the little holes of my piece. But I did not check the box that says multiple passes. So that was created with the same tool, the one that has 3 millimeters of diameter, and then you can see in the simulation the one that is the picture on the left is the one from the face feature. The second one is it's the one from 2D Pocket. This third, the one up on the left is the ones that are drilling the piece, the ones that are making holes to my piece, and well, the little ones, and on the right we have like the bigger circle, like drilled. And finally, that is my circular feature. As you can see on the left, the circular feature is like manufacturing the inner and external circles, and on the right is manufacturing the little holes of the piece. Next, the teacher is going to show you my simulation. I don't. If you have doubts or comments, please let me know. Feel free to ask me or say something. Okay, thank you. It is like okay, that is a circular feature, but can you start on the well? Can you hear me?
Yes, we can hear you. I was speaking to myself. I think I have my mic off. Sorry.
Oh, yes,
I was asking you about the purpose of the circular feature that you use.
oh yes. Well, that was just for well. I was thinking, okay, I already have my operations, so I just think, or I just thought that that would be helpful to have like a smoother piece, como una pieza, like a better design piece, better manufactured piece. But that for me that was like extra work, you know. It it is not necessary at all to have that feature. Your microphone is off. I don't know if
Daniel, if you'd like to explain what we are seeing.
Okay, yeah, well, that is the 2D pocket, which is, as you can see, it is, well, manufacturing the top of the piece. Those are the holes, the little holes that the piece had. There are 8 of them. That was the last one, and then it comes the bigger one. And as I told you before, this was like extra work, just to make sure that the piece is um,
Smooth.
smoother. Yes. It's-
You don't want to hold your hands when holding the piece.
yes.
I-
Well, that one lasts like a little bit long if you want.
to speed it up.
Yeah, you can modify the speed.
Yeah, like that. That's quick enough for you. Okay.
And that was it. As you may see, like the last step, well, the fusion made circles around the little holes of the piece, but I did not check the box that said multiple passes. That was just for have a smoother piece, as said before.
Okay, you select molybdenum steel because you want to use this piece, I think, in contact with water.
The stainless steel,
Yeah, with molybdenum.
yeah, with molybdenum, yes. Well, that's the main reason for stainless steel. So as you know, the water oxidates the piece, and the 316L stops that corrosion.
Well, I'm going to leave you attacks. You didn't change any of the speed parameters of the piece, like your classmates didn't change any speed parameters, but they were working with aluminum. You were working with steel. So
Okay.
I want you to check that, to review that, if the parameters of the speed change between different materials.
Okay, but are you telling me like for the simulation or just for the like the manufacturing?
For the manufacturing.
Okay.
Look, here I'm going to put this operation, the 2D pocket, I'm going to edit. Okay, here on the right we have the feed and speed parameters. We used to leave that like it was presented by Fusion. I want you to check if we have any difference here with feed and speed between different materials. Okay?
Okay. Yes, sounds good.
Okay, very good. Also, I have here your codes, your NC codes. Let me stop the sharing my screen. I already did that. Let me present the code. French. And I'm going to present the French, the code. Okay, as you may remember, this code is what we used to do manually in other subjects, in other quadrimesters. Do you remember? This is named like the G codes because most of the codes begin with the letter G, and we have the X, Y, and Z words. Anyone can tell me the meaning of that words? Don't be shy, guys. X, Y, and Z, what they mean?
The axis.
Okay, yeah. Well, not precisely they are the axis, but if we have X 0.968, Y 27 point, and so on, this line, what is telling us?
The position of the tool.
Yeah, this position where the tool is going to be located. So using this software, we don't have to do all of this line. We don't have to write all of this, right? We just have to design the piece and put some parameters, select the features, and that's it. Okay, do you have any comment or question to Daniel?
No.
Okay. Next one. Next one is going to be Miriam. Are you ready, Miriam?
Yes.
Excellent. Do you want to show us your slide presentation or may I help you?
I prefer to choose the program of Fusion.
The program, not the PowerPoint?
No.
So you are going to share with us your screen?
Yes, teacher.
Okay, perfect. You may proceed.
You can see my screen.
Yes, we can.
I've designed for my design. I select years and a rectangle. For my design, I use the insert CBG tool to make my base. I did this with the intention of using some of the tools that we sound in the past units. For this reason, my base is look blue. Then I extrude all the base into 25 millimeters. Then I insert 4 holes. And this is the specification that I use for the hole. And finally, I insert two image. Is the name of this tool is Deco. I insert the name of my designs is yours, and insert my name. And manufacturing is a few steps. I create a new setup. In machine, I select a generic 3-axis. For stock eyes of model, I select a relative size box. And then I create a face. And this is the tool that I use. Then I create a 2D pocket. This is the specification that I use for the tool. And in stock, I select these chains. In geometry, I select in stock tulip, I put 0. Then I insert drive, and this is a specification that I use for these two. I select this face. My intention is that the tool throw all the material, and for this reason I select this face and this face. And this is a simulation. That's it, teacher.
Okay, they used have a complex geometry, but they were machining pretty easily. That's what's awesome. It took you just one feature, just one operation to do it. Very good. Did you generate the NC code, the G codes?
Yes. It's here.
Yeah, okay, the codes. Okay, guys, do you have any question, any comments?
Awesome work.
Yeah, it got pretty good.
I wanted to use the tool engrave, but
Great,
I
yeah.
have a lot of collision. For I just found the mistake that I how do you say cometí? That's
Remember that
Community.
with the
Right.
engrave operation, you have to select that in your design, okay? Because you use a special kind of tool. Okay, guys, we don't have time to to the next exposition. Sophia, we are going to see your exposition next Friday. This is going to be all for today. I'm going to say thanks to Paloma for being here. I don't know if you have any comment, any feedback to my students.
Yeah, first of all, thank you for sharing this class with me. For me, it was awesome. You guys did it so amazingly. I mean, your level is great. Your explanation and your project was very good also. I suppose that you really fulfill the assignment or the objective that you were asked to. And just great job, you as a professor, that you have been teaching all this to your students, and also your students seem to be very interested, and they are applying everything that they have learned in your class. So thank you, guys. So you did it great, okay? And professor, also, you seem to be a very, very good professor. And thank you.
Thank you, Paloma.
Very good class.
Thank you very much.
Yeah, thank you. So you all got a 10, okay? You all passing it with A. All right.
Okay. Okay,
Great
guys.
job.
See you next Friday. Take
See you
care.
next Friday.